Good evening, everybody. On behalf of the Computer Society of India Coimbatore chapter, I welcome you all to this webinar, Deep Learning from Pixels to Predictions, How Machines Learn. It is being presented by Ms. Sugana, who's a third-year BE Computer Science and Engineering student from the Hindustan Institute of Technology, Coimbatore. So, to begin this session, I would request our chairperson, Mr. R. Saravana Kumar, who's a renowned social entrepreneur, a visiting professor at PSC College of Technology, and former director of Cognizant Technologies, to welcome the gathering. Mr. Saravana Kumar.
Thank you, Durvesh. Ladies and gentlemen, good evening. Iniya Malai Vanakkam. A warm hello to our esteemed participants, the vibrant members of the Computer Society of India, and our star speaker, Ms. Suguna. It's my absolute honor to welcome you all to today's webinar, Deep Learning from Pixels to Predictions, How Machines Learn. In an era where technology is reshaping the world, deep learning stands at the forefront, transforming how machines perceive and interpret the world around us. From self-driving cars navigating busy streets to AI systems diagnosing diseases with precision, the power of image recognition is revolutionizing industries and redefining possibilities. But how do machines see? How do they learn to distinguish a cat from a dog or detect a tumor in a medical scan? Today, we are here to demystify this fascinating journey from pixels to predictions. We are thrilled to have Ms. Suguna, a brilliant third-year computer science and engineering student from Hindustan Institute of Technology, Coimbatore, as our speaker. With an outstanding academic record of 99% in her higher secondary and 8.99 CGPA till date in her BE Computer Science, along with her technical expertise and passion for innovation, she is well equipped to guide us through the intricacies of deep learning and its applications. Her achievements, including active participation in paper presentations, hackathons, and technical events, reflect her dedication and enthusiasm for the field. This webinar promises to be an enlightening experience, whether you are a seasoned professional or a curious learner. We'll explore the fundamentals of neural networks, the magic of convolutional layers, and the real-world applications that are shaping our future. Let's embark on this exciting journey together and explore how machines are learning to see the world. Without further ado, let's begin. Over to our MOC to proceed further. Thank you.
Thank you very much, sir. May I now call upon Dr. Radha Damodaram, who is our MC member of the CSI Coimbatore chapter, also the Chief Executive Director of iBuds Montessori Play School, Director of Skytel Connect Private Limited, and Director of White Hat Junior Private Limited, to introduce this evening's speaker, Sugana. Ma'am?
Yes, sir. Thank you so much. Good evening, one and all honorable present here. It is my great pleasure to introduce our chief guest for today's webinar, Ms. Suguna. She is a passionate and driven third-year BE student in Computer Science and Engineering at Hindustan Institute of Technology, Coimbatore, with an impressive academic record, having secured an 8.99 CGPA till her fifth semester. Suguna has consistently demonstrated her commitment to excellence, both in her academics and various extracurricular activities, such as participating in national paper presentations and prestigious competitions like the Smart India Hackathon 2024. Her technical skills span a range of programming languages including C, C++, Java, and HTML, and she has keen interest in full stack development. Suguna's creativity, solving skills, and strong work ethic have with us today. And we look forward to her insights and inspiring words. Please join us to welcome our chief guest, Ms. Suguna. Thank you.
Now I call upon Ms. Sugana to present to us this evening. Ms. Sugana?
Yes, sir.
You can start presenting, please.
So I am audible.
Yes, you're audible. Please go ahead.
You are audible. You are audible.
Suguna, please proceed.
Good evening, everyone. I hope you are all doing well. Welcome to today's webinar on one of the most fascinating and rapidly evolving fields in artificial intelligence, like deep learning. Have you ever wondered why self-driving cars recognize pedestrians and how Netflix recommends movies or how doctors use AI to detect disease from medical scans? The answer lies in deep learning, a revolutionary AI technology that mimics the human brain to process data and make intelligent decisions. In today's sessions, we will take a deep dive into In today's sessions, we will take a deep dive into how deep learning works, why it is so powerful, and its real-world applications in fields like healthcare, finance, autonomous systems, and beyond. We will explore neural networks, discuss the latest advancements, and even touch on some ethical challenges. Whether you are a beginner or already familiar with AI, this webinar will give you valuable insights into the world of deep learning. Feel free to engage, ask questions, and let's make this an interactive sessions. Let's get started by understanding the foundations of deep learning and what it is and why it's transforming industries worldwide. Before we dive into the world of deep learning, let me give a quick roadmap of what we'll be covering today. This will be help you follow along and get the most out of the sessions. Here, how my session will unfold by introductions from pixels to features, neural networks, the deep learning of the building block of deep learning, and convolutional neural network, seeing with convolutions, training a CNN, learning from data, and real world applications, and then at last, ethical considerations and future trends. With this roadmap in this mind, let's begin our journey into deep learning by first understanding what it is and why it's transforming industries worldwide. So let's dive into the introductions. The power of seeing. With an example of self-driving cars, imagine a self-driving car navigating a busy city streets. It approaches an intersections where pedestrians are crossing, traffic lights are changing, and cyclists are weaving between lanes. The vehicle must instantly recognize all of these elements, classify them correctly, and make real-time driving decisions to ensure safety. This incredible feat is made by image recognitions, a branch of artificial intelligence that enables machines to process and interpret visual data. Then we will see how image recognitions works in self-driving cars. Self-driving cars rely on the combinations of computer visions, deep learning, and sensor fusions to recognize objects, predict movement, and respond accordingly. Here, how image recognitions plays a crucial roles. First one is capturing visual data. The vehicle is equipped with multiple cameras, for example, radar, light detections and ranging, and ultrasonic sensors. These devices capture real-time image and depth information about the car's surroundings. And the second one is pre-processing the image. Before the AI can make sense of the image, the raw data is processed to remove noise, correct distortions, and enhance key features. This may include edge detections, which identify landmarkings, and color filtering to recognize traffic lights, and object segmentations to distinguish between predestined vehicles and obstacles. And real-time decision makings. After recognizing objects, the AI must interrupt their motions and predict future movements. For instance, if a pedestrian is walking towards the street, the car must be slowed down. If the cyclist suddenly swerves, the AI must adjust the vehicle's path. If a green light turns yellow, the system determines whether to stop or proceed safely. This decision making is powered by a recurrent neural network and reinforcement learning, which help the AI learn from previous driving scenarios and improve over time. Next example is medical diagnosis. By analyzing medical images such as X-rays, MRIs, and CT scans, AI-driven image recognitions can assist doctors in detecting disease with high accuracy and speed. In cancer detections, AI helps identify tumors in mammograms, CT scans, and pathology slides, aiding early diagnosis of cancers like breast, lung, and skin cancers. Radiology interpretations. AI assists radiologists in detecting fractures, infections, and abnormalities in X-rays and MRIs. The next is introductions to artificial intelligence and machine learning. Artificial intelligence is a field of computer science that enables machines to mimic human intelligence by performing tasks such as problem solving, decision making, and pattern recognitions. AI can analyze data, learn from experience, and improve their performance over time without being explicitly programmed for every scenario. Then machine learning. A key concept of AI, a key subset of AI is called machine learning, which focuses on training computers to learn patterns from data. Instead of predefined rules, ML algorithms use statistical techniques to identify trends, make predictions, and adapt to new informations. There are three main types of machine learnings. They are supervised learning, unsupervised learning, and then reinforcement learning. Supervised learning, the model learns from labeled data. For example, recognizing spam emails. And unsupervised learning, the models find hidden patterns in unlabeled data. For example, customer segmentations. And the last, reinforcement learning. The model learns through trial and errors by receiving rewards or penalties. For example, AI in self-driving cars. Together, AI and ML power innovations like virtual assistants, medical diagnosis systems, and self-driving cars, making machines smarter and more autonomous. And the third one is the role of deep learning in image recognitions. Basically, deep learning plays a crucial role in image recognitions, enabling machines to analyze and interpret visual data with remarkable accuracy. At the heart of this technology are only artificial neural networks, particularly convolutional neural networks, which are designed specifically for image processing. Here we see how deep learning enhances image recognitions. First one is feature extractions. Traditional image recognitions requires manual features extractions, for example, edge, colors, and textures. Deep learning automates this process, allowing the model to identify features without human interventions. The second one is hierarchical learning, which has three layers to learn. First one is early layers that detect simple patterns like edge and corners. The second one is deep layer that recognize complex structures like shapes, objects, and face. And the third layer is final layers, which classifies the image based on learned patterns. And then image recognition is also done by convolutional neural networks. Convolutional layers which detects features such as edge, color, and textures, and also has pooling layers that reduce image size while retaining essential features, and also has fully connected layers which combines detected features and make predictions. And the image recognition is also high accuracy and scalability. Deep learning models trained on massive data sets can recognize thousands of objects with high precision. making them ideal for medical imaging, self-driving cars, and facial recognitions. And this webinar overview is a brief roadmap of this will be covered in the sessions. How machine sees through digital image neural networks and how they mimic the brain to process informations, convolutional neural network, the cornerstone of image recognitions, training these networks to learn from data and real-world applications of image recognitions from self-driving cars to medical imaging, and then last, ethical considerations and emerging trends in deep learning. Now that we understand the basic of deep learning, let's dive into how AI process image. When we look at the pictures, we instantly recognize face, objects, and colors. But how does a computer see an image? The answer lies in pixel and features. Let's see how images are represented digitally as pixels. A digital image is essentially a grid of tiny squares, elements called pixels, which is nothing but picture elements. Each pixel represents a small portion of the image and holds numerical values that define its colors and intensity. Here, images are represented by some techniques. The one is pixel grid representations. When an image is stored digitally, it is broken down into a grid of pixels. The resolution of the image, for example, x cross y, indicates that it contains x pixel across and y pixel down, resulting in a total sum of x and y, that is x plus y pixels. The more pixels an image has, the higher its resolutions and the more detailed it can represent. And the next one is pixel color representations. Each pixel is assigned a numerical value that determines its colors. The most common color used in digital images are grayscale image. A grayscale image consists of shades of gray ranging from black, which means 0, to white, which means 255 in an 8-bit systems. And then RGB models, which means red, green, blue color model. In colored image, each pixel is represented by 3 values corresponding to red, green, and blue channels. Combining different levels of R, G, and B produce millions of colors. And other color models like HSV, that means hue, saturations, and values, are used in specific applications like computer visions and graphic designs. And then the image are stored in digital formats such as JPEG, which means Joint Photographic Expert Group, compressed format and good for photos, and PNG, Portable Network Graphics, lossless compressions, supports transparency, BMP, which means bitmap, uncompressed and larger file size, GIF, which means graphics interchange format, supports animations but limited to 256 colors only. Then the next one is concept of features in image. In image processing and computer visions, features are the fundamental elements that help machines understand and analyze image. Features are specific patterns or characteristics in an image that distinguish objects, shapes, and textures. Identifying these features is crucial for tasks like object recognitions, facial detections, and image classifications. There are types of features in image or edge, shapes, and then textures. Edge are abrupt change in intensity, which means brightness. They define the boundaries of objects in an image. They help detect the shape and outline of objects. Here, the common edge detection techniques includes Sobel operators detects edge in horizontal and vertical directions. Canny edge detections, a multi-step process that defines strong and weak edges. And next one is shapes. Shapes are combination of edge that form recognizable structures. For example, circles, squares, and face. Shape detection is useful in gesture recognitions, traffic sign detections, and medical imagings. Technique like Hoff transform help detect geometric shape in an image. And then last, textures. Texture represent the surface patterns of the objects such as smooth, rough, or grain. It is analyzed using methods like Gabor filters and local binary patterns. Then need for deep learning due to limitations of traditional methods. Traditional machine learning methods, while useful in many cases, face significant limitations when dealing with complex, high-dimensional, and unstructured data. These limitations create the need for deep learning, which offers a more efficient, scalable, and accurate approach. Here, why deep learning is essential for automatic feature extractions require manual feature engineering, which is time consuming and depend on expert knowledge. Difficult to extract meaningful features from unstructured data. For example, image, speech, and text, and handling high dimensional and large data sets. Struggle with big data due to limited memory and computational capacity. Feature selection become necessary, which may lead to loss of important informations. And then better performance on unstructured data. Work best on structured data, for example, tables, numerical data, but fail on image, videos, and text. Requires extensive pre-processing to convert unstructured data into structured formats. Then we move to next slide. Neural network, the building block of deep learning. The neural network is a computational model inspired by the human brain. It consists of layers of interconnected nodes, which means neurons, that process and transform data to make predictions. There are three basic structures of neural networks. They are
Excuse me, Suguna, could you please
layers.
enable your video as well so that people can relate your face and voice? It would be great if possible, please.
Sir, here is the current resource.
Okay, okay, it's okay. No issues. If you have any technical challenges, that's fine. Please proceed. Please proceed. Thank you.
The three basic structures of neural networks are input layer, hidden layer, and output layers. This is the first layer of neural network, input layer. It receives raw data, example, pixel values of an image and neural features. Here, each neuron in this layer represents a features from the input data. For example, in an image recognition task, the input layer might have neurons representing individual features. For example, a 28 cross 28 grayscale image has 784 input neurons. Then the hidden layers. These layers perform computations and learning patterns from the input data. Here, each neuron applies a mathematical functions to its inputs, processes them using weights and bias, and passes the result through an activation functions like ReLU and sigmoid. For example, each layers detect simple patterns like edge. Deep layer detect high-level patterns like shapes and objects. At last, output layers. It is a final layer produce the network predictions. Here, the number of neurons in this layer depends on the task by for
Could you
binary
please mute Jayshree Loganathan
example.
or let us remove that Jayshree Loganathan? Durvesh, could you please mute her or remove her, please?
For example, cat uses dog, one neuron with sigmoid activations. For multi-class classifications, for example, recognizing digits from 0 to 9, multiple neurons with softmax optimizations. For example, in an image recognition task, if the network is identifying handwritten digits from 0 to 9, the output layer will have 10 neurons, each representing a digits. In conclusions, a neural network consists of an input layer, which is receiving data, the hidden layers extracting patterns, and an output layers making predictions. These layers work together to process informations, allowing AI models to recognize image, understand speech, and to solve complex problems. The next one is understanding neurons and weights. First, what is neuron? A neuron, also known as node, is a fundamental unit of a neural network. Each neuron performs some required operations, such as first, receives inputs from the previous layers, for example, pixel values in an image, and applies weight. Here, yeah, each input is multiplied by a weight, determining its importance. Then adds a bias. Here, the bias value is added to shift the activation thresholds. The next one is weight.
Sugana, you have been muted. Your voice is not audible, please.
Suguna, could you please unmute yourself?
So am I audible, sir?
Yes.
Yeah, loud and clear. Please proceed. Yeah. Sure.
Let's see why these neurons and weights are important. Neurons perform calculations and decides how data flows through the networks, and weights determines which features, for example, age, texture, and patterns are most relevant to the task. Together, they enable neural networks to learn complex functions, leading to applications like image recognitions, speech processing, and AI decision makings. Let's explore how information flows through a neural network. Think of a neural network like a team of decision makers passing information step by step until they reach a final conclusions. This process happens in three simple stages. They are input stage and processing stage and then output stage. Input stage, which means receiving informations. The first layer takes in raw data. For example, if the network is recognizing handwritten digits, each neuron in the layer represents a pixel from the image. These input values are sent to the next layers, which is pre-processing layer, which is also known as making decisions. The data moves through one or more hidden layers where each neuron does three things. One is multiple inputs by weight and add bias and apply an activation functions. And the third one is output layer, output stage, that is making predictions. The last layer combines all processed informations and makes a final predictions. For example, if the task is digit recognition, the output must be a number of 0 to 9. If it's a classification problems, the output is the category with the highest confidence. Then next will be how CNN work by using an analogy and visuals. Think of a CNN like how human recognize objects. Imagine you are identifying a face in your pictures. You don't scan every pixel one by one. Instead, you recognize feature step by step, detect basic steps like edge, line, colors, and combine edge to form shapes like eyes, nose, mouth, and recognize full objects like human face. Up next, we have convolutional neural network. Convolutional neural network are specialized type of deep learning model designed for processing structured grid data, such as image. CNN have revolutionized fields like computer visions, medical imaging, autonomous vehicles, and facial recognition by enabling machines to analyze visual informations with high accuracy. Let's know that. What we focus on CNN. Why we focus on CNNs? Traditional machine learning methods require manual feature extractions, making it difficult to process image efficiently. CNN automatically learn spatial hierarchies of features, making them far more efficient for image recognitions and classification tasks. Then the concept of convolutions and filters. A convolution is a mathematical operations that applies a small filter, also called a kernel, to an input image. The filter moves across the image, multiplying pixel value and summing them up to create a feature map that highlights important patterns. Think of it as sliding a magnifying glass over an image to detect small details like edge or textures. Then the role of filters, also called as kernels, are the key component in convolutional neural networks that help detect patterns and features from image. They work by scanning an image, extracting essential details like edge, shapes, textures, and objects at different level of abstractions. Before we dive into this topic, we have to know what is filter. A filter is a small matrix that slide over an image and perform an element-wise multiplications followed by summations. Then result forms a feature map which highlights important regions of the map image. Think of a filter of a magnifying glass that detect specific patterns in different part of the image. Let's check out how filters detect features by step. The step one is to choose a file, to choose a filters. A small matrix, which is kernel, is selected depending on the features to be detected. And the step two is apply convolution. The filter slide across the image and multiplies pixel values with the corresponding kernel values, summing the result to form a new pixel value in the output features map. And the third step is extract features. Different filters extract different features, which likes edge detections, texture detections, and shape detections. Edge detection, which detect edge from horizontal, vertical, and diagonal. Texture detections, which identify textures like roughness and smoothness. And last, shape detections, captures object outlines, curves, and patterns. Then let's dive into how CNN learn features. Using back propagations and gradient descents, CNN adjusts filter weights using a technique called back propagations. The model computes the error between predicted and actual outputs. Using gradient descents, the CNN updates filter values to minimize the errors. And learning hierarchical features. Early layers detect simple features, middle layer detect texture and shapes, deep layer detect complete objects, and sharing weights and local receptive fields. CNN share field weights across the image, allowing them to recognize patterns anywhere. Each neuron focuses on a logical regions of the image, that is receptive field. Then edge detections. Edge detection is an essential step in image processing and computer visions. CNN use specific filters, that is kernels, to highlight edge in images. For example, Sobel edge detection filters. A common filter for detecting edge in image is the Sobel filter, which empathizes sharp changes in pixel intensity, that is edges. It has types of Sobel filters. One is horizontal edge detection filter, and another one is vertical edge detection filters. Then lost pooling layer. It is a downsampling technique that reduces the dimensionality of feature maps. It slides over the feature maps and selects important values, ensuring that the network remains efficient while preserving critical information. Their types are max pooling, average pooling, and global average pooling. Its significance are reduce computations, which decrease the number of parameters, making CNN faster. Prevent overfitting, that forces the model to generalize instead of memorizing details. Improve robustness. It handles small variations, for example, slight shift rotations in image. Preserves spatial hierarchy. It retains the most important patterns while discarding unnecessary details. Then shifting our focus to training and CNN. Let's see the concept of training as CNN. The training data is a collection of examples used to teach a deep learning model how to perform a specific task. It contains input features, example, pixel in an image, and in supervised learning, the correct output labels. The model learns from training data by adjusting its internal parameters using optimization techniques like gradient descent. For example, image classifications. Then supervised learning. Supervised learning is a type of machine learning where a model is trained on labeled data. The model learns by mapping input data, for example, X, to correct output labels, for example, Y, adjusting its parameters to make accurate predictions on new data. And it works by collect training data where datasets with inputs and correct labels, and train the model where model learns patterns in the data using algorithms like neural network, deep learning, and SVMs, and make predictions. Here the model predict output for new data. Then evaluate performance where accuracy is tested using validations or test data. At last, improve the models. Here, the fine-tune using techniques like hyperparameters tuning. Then, simplified training process includes forward pass, where the input data flow through the network from the input layer, then pass to hidden layer, and then pass to output layers. Then, calculating error, which means loss computations. Compare the predicted output with the actual outputs. The difference between these two is measured using loss functions. And last, back propagations. Back propagation is the process of calculating the gradient of the loss functions which respect to each weights, uses the chain rule to distribute error back through the layers. And then adjusting weights, which is gradient descent update. Once we have gradient from back propagations, we update the weight using gradient descents. Then the importance of a larger dataset is deep learning. A larger dataset plays a crucial role in training deep learning models efficiently. The quality and quantity of data directly impact the model's accuracy, generalization, and robustness. Then we will see the real-world applications. Identifying objects in image, for example, self-driving cars, surveillance and security, retail and inventory management, healthcare and wildlife conservation. The real-life applications of image classifications like medical diagnosis, which is classifying X-ray, for example, healthy versus phenomena, and social media, which detect incorporate content or auto tagging peoples. And self-driving cars, they recognize road signs and landmarkings. E-commerce, which classifies products for better search results, and agricultures, which identify healthy versus diseased crops. And the next one is medical image analysis, that is medical classification. Input medical image. Here the AI receives an X-ray, MRI, or CT scan. The future extraction is the CNA identify the patterns, for example, tuber, fractures, and any other abnormalities. And then classifications. Here the AI predict the disease, for example, healthy or phenomena. And then decision support. Here the doctor review the AI's finding to confirm diagnosis. Then the facial recognitions. Is work by step process, and the step one process is face detections. The AI locate a face in an image or video. And the step two process is feature extraction. The CNN maps key facial features, for example, eyes, nose, and the jawline. Step 3, encoding the face. The face is converted into a unique numerical representations. And the step 4 is a matching. Then the AI compares the new face with the stored face data too. And satellite lost is satellite image analysis, AI for Earth observations. Satellite imagery analysis uses AI and deep learning to analyze high resolution image from space. Convolutional neural network help detect patterns and classify objects and monitor environments changes over time. Then we see the lost content of this webinar, ethical considerations in AI-powered image recognitions. As AI become more powerful in image recognition, it raises several ethical concerns, including bias, privacy, and misuse. Bias in data and AI models have issues like an AI model learned from data, but if the data is biased, for example, under representing certain group, the AI can make unfair or inaccurate predictions. For example, a facial recognition system trained mostly on light-skinned face may misidentify people with darker skin tones. The solution for this to ensure diverse, balanced datasets and conduct fairness audits on AI models. Then the privacy concerns and surveillance risk. The issues are AI-powered cameras can track individual without consent, leading to mass surveillance and potential privacy violations. For example, some governments use AI for facial recognition in public space, raising concerns about citizen rights. The solution is to establish clear regulations, require user consents, and implement data protection measures. Then embracing trend in deep learning for image recognitions. As deep learning evolves, new techniques and
Okay. See, thank you very much, Suguna. In fact, we have received a lot of questions from people who have joined. So you could go through questions one by one and you could start answering them. And after this, we could take up questions from the people who are there right now. These are the questions which we have received earlier. Please proceed with the answers, Suguna.
how do autoencoders work? The autoencoders work in a simple yet fascinating way. They consist of two main parts. The first one is encoders, the other one is decoder. The encoder takes the input data and compresses it into a smaller, the meaningful representations, often called the latent space. And how to apply an internship in top companies. Good questions. I will expect these questions from you. Getting an internship at a top company requires a strategy approach. First, build a strong foundations in your domain, whether it's AI, software development, or data science. Learn relevant skills, work on projects, and contributes to open source platform like GitHub. Next, create a standard out resume. First, you create standard out resume and LinkedIn profile, showcasing your skills for projects and achievements. Many top companies look for hands-on experience. So, participating in hackathons, Kaggle competitions, and coding challenges. Connect with the professionals on LinkedIn and attach tech events and reach out to recruiters. And apply through official career pages, internship portals, and referrals. Then detailed view about placements with high package. Yeah, it's also a wonderful questions from you. Securing a high paying placement requires a combinations of strong technical skills, problem solving ability, and industry knowledge. Companies offer high package, look for candidates will expertise in AI, especially in AI and machine learning, like data science, software development, and also cloud computing. Top recruiters like Google, Microsoft, Amazons, and startups seek individuals who are not just technically strong but also have good communications and analytical thinking skills. Prepare well for coding test, design, system designs, and behavioral interviews to maximize your chances. With the right strategy, continue learning, and persistence, you can secure a placement with an impressive package. Yeah, keep working towards your goal, and success will follow, and success will follow you. And then, what are the things are to prepare before second year? Yeah, it's also amazing questions. Before your second year, focus on learning programming. um, Before your second year, focus on learning programming language like Python,
Yes.
C++, or Java. Build strong foundations in DSA, which means data structures and algorithms, and database and problem solving.
Yes.
AI, web development, or cyber security, whatever it is, to find your interest. Participate in hackathons, coding tests, and online courses.
Yeah, because
The networking and internship will also give you an edge in future placements, right?
yes,
Any practical works are provide for clear understand. Yes.
yes,
Gain practical knowledge in deep learning, works on hands-on projects, contributes to open source repositories, and participate in Kaggle competitions.
access. Office is the admin access.
Platforms like Coursera, Udemy, and GitHub offer real-world datasets to experiment with. And internship hackathons and research papers are also great way to enhance your understanding. Yeah. Next one is deep learning in agriculture domain. Yeah, deep learning helps in crop disease detections, yield predictions, soil analysis, and smart irrigation systems. By analyzing satellite image and sensor data, AI provide precision farming and reducing cost and increase productivity also. And deep learning in mathematical applications, can you please guess out? Yeah, deep learning is transforming mathematics through symbolic computations, equation solvings, and theorem proving, and automated reasonings. Neural network help in pattern recognitions, optimization problems, and algebraic structure analysis. And then deep learning tools and other possible tools. Yeah, popular deep learning tools includes TensorFlow, PyTorch, Keras, OpenCV, and Scikit-learn, Xcrit-learn. And other useful tools includes Google Colab for cloud-based computing, especially Hugging Face from NLP, and Fast AI for simplified model building. And next one is give the information about deep learning, not a professional side complete benefits. Yeah, good. Even if you are not a professional, deep learning can be useful for automations, stock market predictions, and personal projects and business insights. Learning AI can improve career opportunities and help in decision making across various industries. And how does convolutional neural network process image? CNN process image by applying filters that detect edge, shape, and patterns. The layers capture features step by step, allowing the model to recognize objects, classify image, and extract meaningful informations. Then, how the deep learning is covered in IT industries. Yeah, good question. Deep learning is widely used in IT industry for chatbots and recommendation systems and cyber security and NLP, natural language process, and fraud detections and automations. It powers AI applications in Google, Amazon, Microsoft, and startup worldwide. So, any extra questions? How to become a good code master then from scratch? Yeah. Start with Python, C++, or Java, and master DSA and algorithms. Solve problems on LeetCode, CodeChef, and HackerRank. Contribute to open source projects and build real world applications to improve your skills. And how to develop a deep learning products tools to use. To build a deep learning product, define a problem statements and collect quality data and use tools like already told TensorFlow, PyTorch, and Keras. Train, test, and deploy the model using cloud platform like AWS and Google Cloud and Azure. How will deep learning helps in cybersecurity? Good question. Deep learning enhance cybersecurity through fraud detection and anomaly detections, threat intelligence, and malware classification. AI models analyze network traffic to detect cyber threat in real time. Yeah. Is it possible to create a completely unbiased machine learning models? If not, then why? If yes, then why? If not, means bias exists in data collections and human decisions. Model learn from biased data only. Yeah? If yes means by using diverse data sets, fairness aware algorithms, and ethical AI practices, we can reduce bias but not fully eliminate it. Okay. Yeah. Next one is its uses update and Society of India using updates. AI is revolutionizing India through smart agriculture and healthcare and governance. Startups and governments projects are integrating AI to boost efficiency and job opportunities and also in innovations. And then machines are replications of humans. Yeah. Machines can mimic human intelligence but lack creativity, emotions, and consciousness. While they excel in automations, decision making still requires human innotations only. Okay. Need clearance about placements and skills. Yeah. To secure placements, focus on DSA projects, internship, and networking. Learn industry relevant technologies like AI, top technologies like AI, cyber security, cloud computing, and coding and behavioral interviews. Right. Then role of mechanical engineer in machine learning. Mechanical engineer can apply ML in predictive maintenance and automations, robots, and IoT, that is Internet of Things. Learning AI expand career opportunities in manufacturing and aerospace and industrial automations. Yeah.
Okay, since we are not have not receiving any questions, I think we'll move on to the next section, which will be the announcements by our chairperson, Mr. Sarvana Kumar.
Thank you. Yeah. Before we dive into announcement, I would like to extend my heartfelt thanks to our today's speaker, Suguna, for her insightful session on deep learning from pixels to predictions, how machines learn. Your presentation was very much informative. Suguna, thank you for sharing your expertise with us. A special note of gratitude goes to everyone who made time in their busy schedules to join us, especially on the significant day of Shivratri. We are honored to have participants not only from across India, but also from around the world. I would like to extend a warm thank you to Mr. Aji Sentoso, an esteemed industry expert, IT expert from Indonesia, for joining us all the way from afar. Your presence means a great deal to us, Aji. Thank you so much. Aji, could you please share your feedback about our, webinars that we are having as part of Computer System India Coimbatore chapter? I understand you have already attended a few of our earlier sessions. Could you please share your feedback?
Yeah,
Quick feedback, please.
thank you, Saravana. This is the second time I joined this webinar from your organization. Yeah, it's good for me to get more knowledge regarding your topic. It's quite new for me. It's good to join this kind of session. Thank you, Saravana.
You're always welcome. And please do stay tuned and please join our future sessions as well. Santo, Aji, thanks a ton for joining us all the way from there. Though it's very late, extremely late for you, but still you have, allocated your precious time for joining this session. It means a lot to us, Aji.
Yes,
Okay.
yes. Okay, thank you, Saravana.
Continuing with announcements, we host regular knowledge sharing sessions, at least 2 per month, on the second and fourth Wednesdays. The second Wednesday features subject matter expert sessions, while the fourth Wednesday highlights student speaker sessions like the one we enjoyed today. These events offer a dynamic platform for students to share their insights alongside experts from academia and industry. Inclusivity remains a core priority for us. Recently, we have conducted 2 specialized webinars for visually challenged students. With more such initiatives in the works to ensure everyone has access to growth opportunities. Looking ahead, we are planning a range of exciting programs, including faculty development programs, industry workshops, and collaborations with other CSE chapters in Region 7, which includes Tamil Nadu and Kerala, for impactful regional events. We are also designing.
Thanks anyway. On behalf of the Computer Society of India, Coimbatore chapter, I am here to propose the vote of thanks for today's webinar on deep learning from pixels to predictions, how machines learn. The webinar was handled by Ms. Suguna, a third-year student of Hindustan College of Technology. She is learning BE Computer Science and Engineering. The presentation was in an elegant manner, and CSI is always bound to show our gratitude to Ms.